Assalamu alaikum wa rahmatullahi wa barakatuh. Dear students, in this session I'm explaining Poisson distributions. Also you can pronounce it like Poisson distribution. Again, the difference of Poisson distributions from binomial distribution is very simple. In binomial distributions, we had number of independent trials, but in Poisson distributions, we have a fixed interval of time. Fixed interval of time. Okay, what does this really mean? So in binomial distributions, we were just interested to know the probability of success in a given number of events, right? In a given number of trials. But in Poisson distributions, we just try to know about the possible outcome or the probability of outcome in a given number of time or space, you can say, in a given time. Okay, here we have an example. Look here. A bakery sells 3 cakes per hour on average. What is the probability that exactly 5 cakes are sold in 1 hour? Now here we are interested about 1 hour. That this can be 1 week, 1 month, 1 year, or a fixed interval. So if a bakery is selling 3 cakes per hour, what's the probability that exactly 5 cakes are sold in 1 hour? So now here we are not interested to know about the 5 cakes in number of intervals. No, we are interested to know about the probability of selling 5 cakes in a fixed interval, which is 1 hour here. Okay, for this kind of question, we have a special formula that is in Poisson. Okay, the informations you need for this is the number of cakes, which is average, that is shown by lambda, and the lambda is 3 here. And the number of cakes you are interested to know about in the given interval, that is x. We call it x. This is the number of possible events we are interested to know about, that is 5. Okay, once you have these two informations, the lambda, which is the average cakes, and the number you just need to know about, which is x, then you can just plug it in the formula. We have the probability of x given x, but this is for Poisson. Okay, that is equal to lambda raised to the power x into e raised to the power minus lambda over x factorial. Okay, it looks scary, but indeed it's not. It's very much simple. Lambda is the average, that is the average event in the given interval, and e is a fixed number, which is called Euler number. Approximately that is 2.718, that is already given. And then we have x factorial. Once you put all these informations in this formula, when you plug it, right, simply just 3 raised to the power 5 and e, which is the Euler number, already given, just like a fixed number. We have a number in pi. Similarly, we have a number of e, which is fixed, raised to the power minus 3, the value, right, when you plug it and compute it and divide it by the 5 factorials, you have 0.1008, or you can say 10.08%. Okay, so you can say the probability of exactly 5 cakes, that is 10.08%. Very much simple, dear students. It look difficult and complicated, but indeed it's not. It's very much simple. If a company is producing 3 cakes per hour on average, this is per hour on average, you just try to know what is the probability of exactly 5 cakes in 1 hour. Just you must know these two informations. The lambda must be given and the number of x must be given, and just plug it simply and you can get an answer. Okay, have to find the probability, the Poisson probability distributions using Excel. Okay, look here, dear students. Okay, here we have same question. Okay, we call this is lambda. Okay, here we have a question, dear student. A company sells on average 5 units per week. Sales happen randomly and independently over time. What is the probability distributions of selling 0 to 10 units in a week? Okay. Now we know in our question, the same question, we know that the lambda, which is representing the average value, which is x, and that is 5. Sorry, which is this lambda is not x. This is the average value that is produced in a given interval. And this is our x. We just try to know what is the probability of 0, what is the probability of 1 unit when they are sold, what is the probability of 2 or 3 or 4, in this way, once the average is given, which is the average lambda. Okay, now dear students, for this, just equal sign, and just you should type Poisson. Okay, when you just type Poisson, we have Poisson distribution. Click here, and this is our x. Okay, this is the number we are interested to know about, x, and then the mean, this is lambda, this is our mean value. Click here and just press F4, and then again we just try to find out the exact probabilities here. We are not interested in cumulative probabilities, so that's why you should put false here and press enter and then drag it down, and after that you can have all the probabilities. Click on percentage to use in pro. Okay, so you can say if by average, okay, this one is remaining. You can say if by average a company is producing 5 units, what's the probability of 0, 1, 2? But in our example, if by average a company is producing 3 units, right? So what is the probability of 0, 1, 2, 3, 4, 5? Once again, a company sells an average 5 units. Okay, just to make it specific to our example, if a company is producing how many? 3 units. If a company sells an average 3 units per week, this is per week, sales happen randomly and independently over time. What is the probability distributions of selling 0 to 10 units in a week? Okay. Okay, this is week. In our example, we have R. You can change all these, okay? So you can say if the average sale that is 3 units, right? Then what is the probability of 0? What is the probability of 1, 2, 3, in this way up to 10? Now, all these probabilities, they are based on Poisson probabilities. Why? Because we are just dealing to know, we are just interested to know about the probability in given interval. And the given interval here is 1 week. So for this, the condition is the average per week must be given. Then you can find out the distribution, the probability of many different numbers around this average. And just when you just try to check what is the graph here, click on this and go into insert, and we have bar graph. Why? Because for all discrete values you should use bar graph. So look at your students, you can clearly see that the probability of 3 and 4 here, the probability of 3 and 4, they are at the highest. But we have the 22 and 16, they are highest, right? But here we have 3 and 4, but here is starting from 1, but we have here starting from 0. Just to correct it, right click, select data here and click on edit and take this data, okay, exact data starting from 0. Now you can see all correct. Okay, so now the two numbers which they have highest probability, that is 2 and 3. Why? Because they have highest probability, and here you can say 2 and 3, they have a highest probability. Okay, to conclude, dear students, in Poisson distributions, a company sells an average 3 units per week. What is the probability if the company sells 0, 1, 2, 3? Once we just try to know about many probabilities, this is what is called probability distributions. And just you can put it in the graph, and you can see how these values, they are scattered around, how they are looking closer or farther than average, which is the average is 3. Okay, hopefully the Poisson probability is also clear.